and fractal geometry is apparent everywhere in the nature. So you could see that fractals are really present everywhere in nature. Now I would like to summarize the experimental part. We have seen how entanglement results in non-local communication. Such communication happens instantaneously, without any time delay whatsoever. We have seen how DNA, emotions and intentions change the properties of matter, and how our bioenergetic field responds to future emotionally significant events. And finally, the fact that fractal and not Euclidean geometry is best for describing nature. We cannot use Euclidean geometry to describe a tree, for example. We tried this when we were kids, when we drew a rectangle with a circle on top. However, nature doesn't operate on Euclidean geometry, but on fractal geometry that has been only theoretical until the age of computers. A fractal can nicely mimic a tree and it's repeating self-similar structures. As I have already mentioned, more and more scientific evidence points out that our reality is of a holographic nature. This includes us, and particularly our brains, that seem to be working on a holographic base. Increasing evidence is also showing us that the universe might be a giant hologram, and this should come as no surprise, having already seen that nature is based on fractal geometry that governs the same idea as a hologram, which is that every single part is complete in itself and reflects the whole. It isn't that the world of appearances is wrong. It isn't that there aren't objects out there at one level of reality. It's that if you penetrate through and look at the universe with a holographic system, you arrive at a different view, a different reality. And that other reality can explain things that have hitherto remained inexplainable scientifically: paranormal phenomena, synchronicities, the apparently meaningful coincidence of events. A hologram is a pattern produced on a photosensitive medium that has been exposed by holography and then photographically developed. A hologram is produced when a single laser light is split into two separate beams. The first beam is bounced off the object to be photographed, in this case a star. Then the second beam is allowed to collide with the reflected light of the first, and the resulting interference pattern is recorded on film, a piece of holographic film containing an encoded image. To the naked eye, the image on the film looks nothing like the object photographed, and it's composed of irregular ripples, known as interference patterns. However, when the film is illuminated with another laser, a three-dimensional image of the original object reappears. The most interesting thing about the hologram is that, unlike normal photographs, every portion of a piece of holographic film contains all the information of the whole. Thus, if a holographic plate is broken into fragments, each piece can still be used to reconstruct the entire image. Starting with Karl Pribram, who first suggested that the brain is holographic, more and more neurologists are inclined to this idea, as it is so powerful that it explains previously unexplained details about the brain's extremely efficient functions and memory storage. Starting with Karl Pribram, who first suggested that the brain is holographic, more and more neurologists are inclined to this idea, as it is so powerful that it explains previously unexplained details about the brain's extremely efficient functions and memory storage. What Karl Lashley did was to train rats to perform a variety of tasks, such as running round a maze. Then he surgically removed various portions of their brains and retested them. His aim was literally to cut out the area of rats' brains containing the memory of their maze running ability. To his surprise, he found that no matter what portion of their brains he cut out, he could not eradicate their memories. Often the rats' motor skills were impaired and they stumbled clumsily through the mazes, but even with massive portions of their brains removed, their memories remained stubbornly intact. For Pribram, these were incredible findings. If memories possessed specific location in the brain in the same way that books possess specific location on library shelves, why didn't Lashley's surgical plunderings have any effect on them? Patients who had had portions of their brains removed for medical reasons never suffered the loss of specific memories. Removal of large sections of the brain might cause a patient's memory to become generally hazy, but no one ever came out of surgery with any selective memory loss. Similarly, individuals who had received head injuries in car collisions and other accidents never forgot half of their family or half of novel they had read. Even removal of sections of temporal lobes, the area of the brain that had figured so prominently in Penfield research, didn't create any gaps in persons' memories. Holography also explains how our brains can store so many memories in so little space.